Okay, so we're gonna start with dividing using synthetic division from yesterday. So remember, we're gonna solve for this, setting it equal to 0. So we're gonna subtract 2 from both sides. So in your half box, we're putting -2, okay? So you gotta solve. Now we're gonna look, this is in standard form, of course, but we're missing the x squared. So we're gonna have 1, 0, okay? Then -3, and then we're gonna have 5. So you gotta put that 0 in there. Bring down the 1. 1 times -2 is -2. That becomes -2 when we add straight down. -2 times -2 would give me +4. That would give me 1. 1 times -2 would give me -2. And that gives me 3. So we had a power of 3 here. So this is gonna be x squared minus 2x plus 1 plus 3 over what we divided by, which was x plus 2. Hopefully you executed that. Questions there? Yeah.
So then what happens to the x squared
Where at?
that we put in the 0 for?
What's the,
Wouldn't that be squared then?
no.
Oh.
Well,
Oh, yeah, wait.
we're dividing by x, so everything's going down 1, okay? All right, now, so, synthetic substitution, of course, 5's already solved for. Remember, we're trying to find p of 5, basically. What would be the remainder? All right, standard form, we're good. 1, 3, we need another 0 because we don't have it for the x. And then -6. 1 comes down, that gives me 5. That gives me 8. That gives me 40. That gives me 40. That gives me 200. That gives me 194. So p of 5 is 194. So that means that's a coordinate, isn't it? 5 for x, 194 for y is a coordinate there. Questions there? Everybody good? Repeat the same process for the next number, which is -1. Going to use the same coefficients, 1, 3, 0, -6. Bring down 1. 1 times -1 is -1. That gives me +2. That would give me -2, which would give me -2 here. And that's going to give me +2, which gives me 4 here. So p of -1 is equal to 4. So -1, 4 also is a point on the coordinate plane of that particular quadratic. How we doing? Make sense, everyone? Synthetic division. When we do synthetic division, we're going to add those x's in at the end right here. When we do synthetic substitution, all we're really interested in is your xy coordinate. There are 2 different things there. Is everybody clear? That wants to be. Not everybody really wants to be. As you start scheduling, some of you probably, it's shortly, isn't it? They're starting to talk about it. You have CP or you can do pre-calc. I put you in one or the other. So if it comes along and you don't like where you're at, let me know when you go to see your counselor and we can try to switch it. Okay, but I did suggest, I did offer a suggestion for where I thought you should be, okay? But we can talk about that if anybody wants to, or you don't like what's going on there. Clear on that? All right. Let's move on. I don't know what happened there. Let's see. I guess we're moving on because that's over. All right. Gonna do a couple things in 6-4 today, so You should feel okay about that. Let's start by doing a quick synthetic substitution. Let's do synthetic division on this problem real quick. Take a second. I know we just did one. This one's a little bigger and a little longer. What's going to go in our half box? Positive 6. So positive 6 is going in our half box. Do we need to put any zeros in here? I think we're all right, aren't we? 1, negative 3, negative 28. $59 and 6. Getting some big numbers there with those numbers, 28 and 59, huh? Let's see, we're gonna bring down the 1. Gives me 6 here. Give me 3 here. It's gonna give me 18 here. It's gonna give me negative 10 here. It's gonna give me negative 60 here. Give me negative 1 here. Give me negative 6 here. Give me 0. A remainder of 0. So think about that. 6, 0 is our xy coordinate, isn't it? When we have a remainder of 0, that's going to be one of our roots. Now, if we did do synthetic substitution, that would be done, but we said synthetic division, so we divided. So now we are looking at x to the 3rd plus 3x squared minus x minus 1. And really, that's set equal to 0 because we factored out. So in fact, if you're grasping this concept, this is left over, okay? And we factored out x minus 6. We took the binomial x minus 6 out. I don't know if that makes sense to you. We took x minus 6 out because it is a perfect factor. So just like factoring a quadratic, we're going to factor polynomials here next, well, not after next week, following, start the new semester. We're at the end of the 9 weeks. Of course, we got next week yet. Okay, so keep looking at your grades and something you're missing. You know, we can figure out something to help you out. Michael, is that what you're doing? You're looking at your grades right now? Oh, I just wondered that you were intently looking at your computer. I thought maybe you're checking your grades out. Questions here? Come on, that's fine. Thanks. All right. We're going to get right to this section 8.4, or 6.4, I'm sorry, and we're going to do a couple of things today. We are going to do factor by grouping. Just a small little assignment today. So we're starting to get into factoring polynomials. Okay, so we've started with linears. We factor a lot of quadratics and get 2 roots. Polynomial is going to have a lot more roots. Okay, so we got to come up with a way to do it, and this synthetic substitution is going to help us. We're going to be looking for when we get a remainder of 0. If the remainder is 0, then it is a factor. It's that simple. Okay, so we're going to use that. That's called the factor theorem to determine if a polynomial. It's basically nothing new. We're just going to do synthetic substitution and look for a remainder of 0. That's all. And I particularly don't know if I'd even write any much of this down. Let's just get right to it and try one of these problems right here. All right. And again, you can go back and look at this. This is basically saying that the remainder is 0. Okay, so let's do synthetic substitution on this problem right here and see what the remainder is. Just what we just got done doing. So with substitution, all we're basically looking for is what the remainder is. If the remainder is 0, then we know that x equaling -1 is a factor of this quadratic. So -1 going in our box, our half box, coefficient of 1, -3, 1. Bring down the 1. 1 times -1 is -1, that gives me -4. -4 times negative will give me +4, so I have 5. So this answer is either true, okay? So the answer here is either yes it is, or no it's not. Does that make sense to you? And this one is? No. Why? The remainder is not 0. It's not a factor. So we're going to use this synthetic substitution to find the remainder, and when the remainder is 0. So this really is a point -1 for my x, and 5 for my y, isn't it? It's not going through the origin, it's not going to the x-axis, it has to be, your y value would be 0 if it's going through the x-axis, which would be one of our solutions. See if that is a factor. Last one of these, and then we're gonna do our last thing for today, some grouping. See if that's a factor. Synthetic substitution. Freshman basketball, we won last night. Went over to Perry, got the victory. How about that, Luke?
On the side. Our first one of the year.
It's always good to get off to 0, you know what I mean, Slatezy?
Yep.
All right, half box is -2, don't mess that up, does everybody know why? Okay, got solved there. Let's see, we got bad golf shot 4, we got -2, we got 5, we bring down that guy right there, and that's gonna give me -2, is that right? That gives me -4. I feel like I'm doing something wrong, am I doing it right so far? I think so. I brought down, what did I bring down 1, anybody know? I knew I was doing something wrong. What am I supposed to bring down here? 4, come on, folks. 4 times that would be -8. Okay, which gives me -10, and that gives me +20, which gives me 25. Is it a factor? Yes. How do you feel about that? Okay, that skill's not too bad, is it? Everybody feel okay? Last skill of today. And that is factor by grouping. This can be a little bit tricky for students. First of all, it only happens if I have 4 terms. Okay? So I have to have 4 terms. So step 1, or step 2, or step whatever, step 1, you gotta look for 4 terms. If it has 4 terms, I might be grouping. Step 2, G, CF. So I'm gonna group these first 2. That's why it's called grouping. I'm gonna group the first 2 and take the greatest common factor. What's the greatest common factor out of those 2 things? Anybody? What can come out of both terms? All right, x squared. What's gonna be left is x minus 1. Remember, we take the whole thing out, we gotta hold that spot with a 1, right? What can I take out of the next two if I group these? I'm gonna group this together. What can come out of that? 25, right? I'm gonna take it one step further, I'm gonna take negative 25. And I'll show you why. If I take negative 25, that's gonna become positive x minus 1. So I group, so step 1, it has to be 4 terms. Without 4 terms, you can't do grouping. Step 2, I group the first 2, get a GCF, group the second 2, and get a GCF. Now, why is that important? Because step 3 is I need the same. And what do I mean by that? Well, after I group and take a GCF, my leftovers that hang out in the back of the fridge have to be the same. So I need x minus 1 and x minus 1. I need to be the same. If they're not, you can't group it. Step 4, I'm going to rewrite. Okay? So, look, if I distribute this, if I distribute x squared, am I going to get the exact same thing back? If I distribute negative 25, if I distribute those numbers, I'm going to get the same. Now, but I can rewrite this as x squared minus 25 as a binomial and x minus 1. In fact, this starting 4 term, this and this are basically all equal. I'm just changing how they look in their little bracket. Because look, if I distribute x squared over those and I distribute negative 25 over, am I going to get that original problem? Yes. So the question is, hey, everybody asked me, hey, Mr. Grubb, where'd the other x minus 1 go, right? Well, it's still there. Isn't it the same? X squared distribute? And hopefully you see that. We're real close to being done with this factory problem. We do have something special here, and that is this guy right here. Does anybody recognize what that is from our factoring earlier here? Difference of perfect squares. So we're almost done with this. So see if there's any factoring to do. That would be step 5. See if you can factor any of the binomials. Factor the bi's, nomials. If you can factor the binomials, you can. This guy does. X minus 5. X plus 5. And x minus 1. So these are all equal. So look, we started with this guy up here. It said to factor. How many terms do we have? How many possible roots? Well, it's a degree of 3. So we have some. We have 3 binomials that we factored out of that guy. Let's review. You can only do this grouping if what? How many terms do you have to have? 4. Take the first set, look for a GCF. Take the second set, look for a GCF. Now, when you get that GCF, you got to get what? You got to get the same leftover. Then rewrite. Then this step, not always, sometimes you can find a possible factor. It has to be the difference of perfect squares. Try this one. What can come out of those first 2 terms? See what you can get. What can come out of those second 2 terms? And then see if you can get the same thing after that. X squared coming out of those first 2, right? Remember, I got to get the same. I need to take something out now that's going to give me x minus 2 and then leftovers. 11 lot of times when we're at this point, we're gonna take a negative. So we are need to take negative out of here. What are we gonna take? -9. Which leaves me with x minus 2. Remember, you can always go backwards, distribute, see if you check your answer if you get it right. So step 1, I had 4 terms. Step 2, we took the GCF. What was step 3? Rewrite. Okay, so let's rewrite. Again, remember, this guy here is equal to this guy. These are all still equal, aren't they? They're all still exactly equal. Is there anything special here on any of these binomials? Yes. The first one is the difference of perfect squares. So to finish this guy out, factor if possible, we're going to have x minus 3, x plus 3, and x minus 2. How are we doing? Everybody okay? Tonight, you're gonna practice a couple of these grouping problems, that's all, and you're gonna submit, okay? It's on page 433. All right, that's all. I'm just gonna do a couple grouping problems, nothing else. Page 433, 439. Enjoy your weekend. Go Buckeye, well, we'll see the Buckeye, but go Browns, right? Browns play Sunday night, so that would be an upset, I'm sure, if we can pull that off. Thanks again for your time today.